Now we are going to solve the problems under unit exercise 1. Let us do it one by one. The first question is, if the ordered pairs x square minus 3x, y square plus 4y and minus 2, 5 are equal. So when these two are equal, we have to find the values of x and y. So x square minus 3x, y square plus 4y, which is equals to minus 2, 5. According to the question, these two are equal. So we have to pair it, first element with the first element, second element with the second element. Let us do it. X squared minus 3x is equals to minus 2. X squared minus 3x plus 2 equals to 0. Now we will find the factors of this. What we should get? If we multiply, we should get it as 2. If we add or subtract, we should get it as minus 3. We have to choose the factors in such a way. What shall we choose? Minus 2, minus 1 let us choose, because minus 2 into minus 1 will become plus 2. Minus 2 minus 1 is minus 3. So x minus 2, x minus 1 which is equals to 0. Simplifying, x minus 2 equals to 0, therefore x is equals to 2. X minus 1 equals to 0, therefore x is equals to 1. The values of x are 1 and 2. For the second one, y square plus 4y equals to 5. Y square plus 4y minus 5 equals to 0. Similarly, multiply minus 5, add 4. We have to choose factors in such a way. 5 into minus 1 let us choose, because 4 has a positive symbol. So the bigger number among these should have a positive symbol. Okay, so 5 into minus 1 will give us minus 5. 5 minus 1 will give us 4. So y plus 5, y minus 1 is equals to 0. Simplifying this, y plus 5 equals to 0, y equals to minus 5, y minus 1 equals to 0, y equals to 1. The values of y are 1 and minus 5. Next problem is the Cartesian product of A cross A. So the same set is crossed product, has 9 elements. So A cross A has 9 elements, that is n of A cross A is 9, among which, that is among 9 elements, the 2 elements are given. We have to find the set A and the remaining elements of A cross A. It is very easy to find, because 2 elements in A cross A is given. A cross A in the sense, so A value will be of minus 1, 0 and 1. So we found the elements of A. If we cross product A with A, we will find the remaining elements. So A cross A is minus 1, 0, 1, cross product it with minus 1, 0, 1. A cross A equals to minus 1, minus 1, minus 1, 0, minus 1, 1, 0, minus 1, 0, 0, 0, 1. Next is 1, minus 1, 1, 0, 1, 1. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements, and the 2 elements among which are minus 1, 0, where it is found here, and 0, 1. It is found here. So removing these elements, we have remaining 7 elements as an answer. Third problem is given as, given that f of x is equals to square root of x minus 1 when x value is greater than or equal to 1, that is 1 is included, and f of x value is 4 when x is less than 1. 1 is not included here, and we need to find f of 0, f of 3 and f of a plus 1 in terms of a. We will do one by one. So first let us plot the values in a graph. We will consider the x-axis. So when x value is greater than or equal to 1, 1 is included, that is why I am using closed brackets. F of x is equals to square root of x minus 1, and f of x value is 4 when x is less than 1. 1 is not included, therefore I am using open brackets. F of x is equals to 4. This we will consider as interval 1, this we will consider it as the second interval. First we have to find out f of 0. So f of 0 means x value is 0. The 0 value falls in the first interval. We should use the f of x value as 4. So f of x is equals to 4. If I substitute in place of x as 0, I will get only 4. So f of 0 is equals to 4. Second option is f of 3. Now x value is 3 and it falls in the second interval. Therefore we should use f of x is equals to square root of x minus 1. F of 3, substituting the value of x as 3, 3 minus 1, which is square root of 2. So f of 3 is equals to root of 2. Third option, what we have to do is we have to find f of a plus 1 in terms of a, given that a greater than or equal to 0. A greater than or equal to 0 means a value starts with 0 and after 0 it goes on. Suppose if I take a value as 0 itself, this will become f of 1. So f of 1 means it falls in the second interval. Therefore I should use the f of x value as square root of x minus 1. What should we use in place of x? A plus 1. So f of a plus 1 is equals to square root of a plus 1 minus 1. Plus 1 minus 1 will get cancelled. So f of a plus 1 is equals to square root of a. Next question is, let a is equals to set of values are given and f is a mapping from n to a natural number, be defined by f of n, that is it is defined as, that is given as highest prime factor of n in a. Write f as a set of ordered pairs and we have to find the range of f. Let us do this. Now what we have to do is, a set is given as 9, 10, 11, 12, 13, 14, 15, 16, 17. Where f of n over here is given as highest prime factor. Highest prime factor of n in a. Okay, what we have to do is, now we have to find the prime factor of all the numbers given in the set A. So first we will find out for prime factor of 9. 9 means we should choose only the factors as prime. We have to go from the least. Least prime number is 2. 2 cannot be chosen. So we have to choose 3. So 3 3s are 9, again 3. Only one prime factor, which is 3. Next, prime factor of 10. So similarly for 10, 2 I have to choose 5 times. So 5 is a prime number. 2, 5. Whereas highest of this is 5, because that is what is given, highest prime factor of n in a. Among 2 and 5, 5 is the highest prime factor. Next we have to find the prime factor of 11. 11 can only be chosen by 11. So 11, which is the highest prime factor. Next is prime factor of 12. So 12 I can choose 2 6 times, again I can choose 2 3 times, 3 times 1, 2 and 3, 2, 3, highest among this is 3. Next is prime factor of 13. For 13 also we can choose only 13. So 13, highest is 13. Prime factor of 14. For 14 I can choose 2 7 times, I can choose only 7. So 2, 7, highest among this is 7. Next is prime factor of 15. For 15 I can choose 3 5 times, 5 times 1, 3, 5, highest among 3 and 5 is 5. Next is prime factor of 16. For 16 I can choose 2 8 times, 2 4 2 2, so 2, only 2 is the highest prime factor for 16. Next is prime factor of 17. 17 it can be only divided by it, 17. So highest prime factor of 17 is 17. Now we will write the set of all ordered pairs. Now we will write the set of ordered pairs. For 9 we got the highest prime factor as 3. For 10 we got 5. So 10, 5. Next for 11 it is 11. 11 comma 11, and for 12 it is 3. So 12 comma 3. Next for 13 it is 13. 13 comma 13. Next for 14 it is 7. 14 comma 7. For 15 it is 5. So 15 comma 5. Next for 16 it is 2. 16 comma 2, and for 17 it is 17. 17 comma 17. And the range of f is 2, and we have 3, we have 5, we have 7, 11, 13 and 17. So the range of f is expressed as such. Okay. So now we have to find the domain of the function f of x is equals to this. We have to find the domain for this function. First what will we do is, we will consider this, that is square root of 1 minus x square. Always the term within the square root must be greater than or equal to 0. Therefore 1 minus x square is greater than or equal to 0 because it couldn't be a negative value. First thing is this, and the second thing is, if x is real, then x square must be greater than or equal to 0. Hence, the range for which 1 minus x square is greater than or equal to 0. We have to choose a domain in such a way for which all 1 minus x square is greater than or equal to 0. We are going to choose the domain as x belongs to minus 1 comma 1. Why we are choosing this as a domain is, if we substitute minus 1 over here, what will we get? Minus 1 square will become plus 1, but 1 minus 1 will give greater than or equal to 0. So therefore this equation satisfies. Again similarly, if I take x value as 1, 1 minus 1 will give me 0. Therefore minus 1 comma 1 satisfies this equation. But it satisfies 1 minus x square. We have to check whether this minus 1 comma 1 satisfies the whole function f of x. If it satisfies, we can consider the domain as minus 1 comma 1. Let us check that. So what we are going to do is, first x square, if I take minus 1 comma 1, x square will belongs to 0 comma 1. Because for if x is real, x square must be greater than or equal to 0 and x value is 1 according to the domain. Similarly, first x square we take, it will belongs to 0 comma 1. If I take 1 minus x square, again it will belongs to 0 comma 1. Similarly, if we take the square root of 1 minus x square, it will also belongs to 0 comma 1. Next, 1 minus square root of 1 minus x square if we take, it will also belongs to 0 comma 1. Next, if I take square root of 1 minus square root of 1 minus x square, again it will range between 0 and 1. Next, if I take 1 plus square root of 1 minus square root of 1 minus x square, again it will range between 0 and 1. If I take the square root of 1 plus 1 minus square root of 1 minus x square, it will also range between 0 and 1. So we chose the domain as minus 1 comma 1 for x value. So it satisfies all the equations as it belongs to 0 comma 1. Therefore the domain of f of x is minus 1 comma 1. It can be expressed as x varies between minus 1 and 1. Now f of x equals to x square, g of x is 3x and h of x is equals to x minus 2. We have to prove this. We will do it the left hand side first, then we will check it with the right hand side. Left hand side is given as f composite g composite h. First we will find the portions within the brackets. F composite g with respect to the function x, it can be written as f of g of x. So first g of x value is 3x, f of 3x. Now we have to use the function of f, x square. Instead of x we have to substitute 3x. So 3x square, which will give us 9x square. Next, f composite g composite h. So, f composite g of h of x value is x minus 2. Now, we have to substitute x minus 2 in this f composite g function. It will give us 9 into x minus 2 squared. Expanding this in a minus b whole square formula, a square minus 2ab plus b square. Value of a is x and the value of b is 2. Therefore, 9 into first it is x square minus 2 into a into b, 4x plus 2 square is 4. So, 9x squared minus 36x plus 36. Next, right hand side, f composite g composite h. First we have to find g composite h of x. So, it can be written as g of h of x. G of h of x value is x minus 2. Next we have to use the function g, which is 3x. Instead of x we have to substitute x minus 2. 3 into x minus 2, 3x minus 6. Now we have to use f composite g composite h. So, f of g composite h function is 3x minus 6, f of x is x squared, so 3x minus 6 whole squared. For this also we have to use a minus b whole square formula, but the value of a is 3x and the value of b is 6. We will do it. So, a square is 9 square x square minus 2 into a into b, 2 3s are 6, 6 6 are 36x plus 6 square is 36. Both left hand side and right hand side are equal, hence proved. Let A equals to set is given, B set is given, C and D are given. We have to verify whether A cross C is a subset of B cross D. B cross D. First we have to write A cross C. A cross C can be written as 1, 2 cross 5, 6. We all know to write. So, A cross C can be written as set of all ordered pairs 1, 5, 1, 6, 2, 5, 2, 6. Next we have to find B cross D. B value is 1, 2, 3, 4 cross 5, 6, 7, 8. So, next B cross D will be 1, 5, 1, 6, 1, 7, 1, 8. 2, 5, 2, 6, 2, 7, 2, 8. 3, 5, 3, 6, 3, 7, 3, 8. 4, 5, 4, 6, 4, 7, 4, 8. Now what we have to do is, in order to check whether A cross C is a subset of B cross D, all the set of ordered pairs in A cross B must present in B cross D. Let us check that. 1, 5, yes it is there. 1, 6 it is there. 2, 5, yes it is there. 2, 6 it is there. Therefore, A cross C is a subset of B cross D. Yes it is. So, the next problem is f of x value is given and we need to show that f of x is equals to minus 1 by x provided x is not equals to 0, because if we take x value as 0, anything divided by 0 will become infinity. So, therefore, the x value shouldn't be 0. Let us prove f of x is equals to minus 1 by x. Now, f of x value is x minus 1 by x plus 1. Now, in place of x, this we have to substitute. What it will become? X minus 1 by x plus 1 minus 1 divided by x minus 1 by x plus 1 plus 1. Let us take the LCM. X minus 1 minus of x plus 1 divided by x plus 1 by x minus 1 plus x plus 1 divided by x plus 1. This x plus 1 in the denominators will get directly cancelled. Therefore, we will simplify this. X minus 1 minus x minus 1 divided by x minus 1 plus x plus 1. So plus x minus x will get cancelled, plus 1 minus 1 will get cancelled, minus 1 minus 1 minus 2, x plus x 2x, 2 and 2 will get cancelled, minus 1 by x, hence proved. Ninth problem is the function f and g are given by f of x is equals to 6x plus 8, g of x is equals to x minus 2 by 3. We have to calculate the value of g of 1 by 2. The second subdivision is write an expression g of f of x in its simplest form. So we will calculate g of 1 by 2. g of 1 by 2. So first we have to use g of x function, whereas it is x minus 1 by 2. In place of x we have to substitute 1 by 2. Okay, so it will become 1 by 2 minus 2 divided by 3. So g of 1 by 2, that is 1 minus 2 2's are 4 by 2. If I reciprocate this, we have 3 by 1. If I reciprocate, it will become 1 by 3. I am writing 3 over here. Okay. So 1 minus 4 is minus 3 by 2 into 3. Minus 3 and 3 will get cancelled. Therefore, g of minus 1 by 2. Now what we have to do is, in the same function g of x, in place of x we have to substitute minus 1 by 2. Therefore it will become minus 1 by 2 minus 2 divided by 3. So simplifying this, minus 1, 2 2's are 4, minus 4 divided by 2. If I reciprocate this, this will become 1 by 3, which I am writing it over here. So this will become minus 5 by 6. And the second option is we have to write the simplest form of g of f of x. So g of f of x, g of f of function f of x is given as 6x plus 8. Now we have to use the function of g. In place of x we have to substitute x minus 2 by 3. 6x plus 8 minus 2 divided by 3, 6x plus 6 by 3, taking 6 in common, it will become x plus 1 divided by 3, 2 into x plus 1. 10th problem is we have to write the domain for the following real functions. Real functions. Okay. So first sum, if you see, f of x is equals to 2x plus 1 by x minus 9. This will become infinity when I choose 9 over here, which is 9 minus 9 will give me 0. So this function is not defined only for 9. It is defined for else values of x. Therefore, the domain is x belongs to real number but not 9. Where the domain for this is p of x is defined for all values of x. X could be any value. So x is a real number. Next, here also within the brackets the x value should be greater than 2. Therefore, the domain is, that is, x belongs to 2 comma infinity. It can be greater than any values of 2. And for this problem, h of x is defined for all values of x, that is any real number. We have completed chapter 1 relations and functions. From the next class we will start off with chapter 2 numbers and sequences. Thank you.